Okay, so we are going to get through as much of this as we can, but we are in no rush. We don't have to worry about meeting a deadline or anything. So I want you to just keep going with it. There will be some stuff of this on the final, but we will not take our own test on this. So things are a little different now. We've been using rectangular coordinates a lot where we go over x and up y. And so now we're going to do a new one called polar coordinates where we're going to go r comma theta, where r is like the radius or the distance from the origin, and theta is the angle of rotation from the positive x-axis. So, for example, we're going to graph the point 2 comma 3 pi over 4. So that means that we're going to use, like, our radius is 2, and our angle that we're going to use is 3 pi over 4. So something that might be helpful to notice is that this circle, kind of like a unit circle, but it goes by 15 degrees or pi's over 12. So you could label these all, and I'm going to label at least this one 45. So there's some on here that we haven't had before, some of the 15s. So I suggest that you do the same. And let's see, 195. So I'm just adding 15 in my head every time. And that's something I think that you could do as well. 285, 300. Yeah. 315, 340, 330, 345, and 360. And similarly, count by pi's over 12s. So the only ones that we don't know are the ones that, like, we know this one is pi over 6. And you can go on your old unit circle if you need to, pi over 3. So this one here is 5 pi over 12. And then remember 90 was pi over 2. So then another one that we've not had before is this 7 pi over 12. Not 2, but 12. So then we've got 3 pi over 4. And that's the one we're going to need, right? 3 pi over 4. 5. Oh, I missed 2 pi over 3. I knew something didn't seem right. Whoops. So this is 2 pi over 3. 3 pi over 4. 5 pi over 6. 165 here. 11 pi over 12. And then here we have pi. So I'm going to keep going here. I'm just counting. So 13 pi over 12. 7 pi over 6. 5 pi over 4. And 4 pi over 3. And 17 pi over 12, and one of our other new ones. 270 was 3 pi over 2. 19 pi over 12 is another new one. 5 pi over 3. And 7 pi over 4. 11. Again, you can be copying this off your unit circle. And 345 is the last one that we don't have. 23 pi over 12. And then this, of course, is 2 pi here. Okay, so I labeled my unit circle in 12ths and in 15ths. So kind of going back to the thing that I was doing now, 3 pi over 4. Can't really see it now. And 2. First, you need to find the angle 3 pi over 4. So 3 pi over 4 is over here, like at 135. And then you'd plot. So I found this one here. I'm going to erase this line in a second. So that's the line I'm going to be on. And then I'm going to count out 2 of those concentric ring marks. That's the word I'm looking for. So right here is the point. Out 2, radius 3 pi over 4. Okay. So then this one is different. It has a negative radius. So then this moves opposite of positive r. So what I'm going to do first is find 5 pi over 6. So that should match up with this, like, thicker dotted line. Here's 5 pi over 6. I'm going to mark that. But instead of counting 1, 2, 3 this way on 5 pi over 6, I'm going to count the opposite way. 1, 2, right here. And then this point here is negative 3 5 pi over 6. So you move backwards. The goal first is to find the angle, then you move backwards to find it. So negative means go the opposite direction. So then on the bottom here, it says name 4 different coordinates that represent the point P on the graph. You could use degrees or radians, okay? And I think here you should pause and try to come up with a couple, and then I'm going to write a few. Okay, so, and polar coordinates have these like funky square brackets. That's how we know they're polar coordinates. It's my polar bear. And so, for example, one of these that I'm going to do is 4 and 270. And likewise, I could do -4 and 90. So that would go the opposite direction. I could use 4 and 3 pi over 2. Or -4 and pi over 2. So there's a bunch of different ways that you can write this. How about 4 and -pi over 2, or 4 and -90? Any of those would work. So there are lots of different ways to label points in a polar coordinate. Here are just a few of them. So in terms of like a word problem, it says a lawn sprinkler can cover part of a circular region determined by polar inequalities. So inequalities means like greater than or less than, right? And it says 30 degrees is less than theta, which is less than 210. And, or I'm sorry, -30 degrees, and that r is between 0 and 20. There should be no degrees here. It just should be that my radius is between 0 and 20. So I'm going to remind you of a few things, that the area of a circle is pi r squared. So, and the sprinkler, I'm going to do one of my most famous drawings here. You know, it's those sprinklers, you have them in the ground and they go like, you know, and they sprinkle and then they keep going and then they make that noise where they go and they come back. So I'm sure that was really descriptive and you guys really enjoyed my sound bites there. So it's one of those sprinklers and it kind of like shades in a half circle. So the area of my whole circle here, my radius is 20. So the area of my whole circle would be 400 pi. And that would be the whole circle. I'm going to kind of label this. I'm going to call this one 10 and this one 20, just so I have some room here. Maybe I'll use green to show my yard here. And I'm going to go from -30 degrees. So remember, these count by 15. So -30 is here all the way to 210. So 180 and 30 is 210. So here's 210. But I've noticed that in total, I'm covering 240 degrees. So here's my yard, and my sprinkler sits right there at 0, 0, and is sprinkling back and forth, hitting this 240 degrees. So I'm using 240 out of my 360 degrees is what's getting sprinkled. And that is of my 400 pi amount of area. So if you took 240 divided by 360, you'd get the amount that I was shading, that fraction, and the entirety of my circle is 400 pi. When you multiply those together, I got 838 feet squared. So it's just a quick word problem using polar coordinates. Something that's important here then in polar coordinates is kind of going back and forth between like something that's just like r equals or something that's just theta equals. So just a reminder, like when x equals 5, that means you can give me a bunch of points where x is always 5. And I can plot them on here. 5 over 1, 2, 3, 4, 5, and 7 up. 5 over 7 down. So that makes a line like this. I was really far off. And when y is -3, same thing. Like I can plot a bunch of points where the y value is always -3. And that would look like a line going like this. When you do this in polar coordinates, it's similar where like when r is 5, it could be any angle, but the r is always 5. So 1, 2, 3, 4, r equals 5 is a circle with radius 5. That was another great drawing by me. Circle where r equals 5. theta equals 165 is a line through 165 degrees. So 165 was, so it's 180, so 165 is this light shaded line, and you would just go straight line through. All right, almost done for day 1. Just as this is on our final. This is one everybody forgets, so I'm telling you now, this is on our final. Find the distance between 2 points. So when I'm looking at this, I hope that you're seeing that there's a point here and another point here. So I know this angle here, and I know this distance. And then I know this angle here, and I know this distance. And because of that, if I know the two angles, I could subtract them and come up with this angle inside here. So I've got a side angle side triangle. And if you remember way back to chapter 5, we could solve a side angle side triangle by using the law of cosines. So I know that this does not, or it looks like it could be a right triangle, but it isn't necessarily a right triangle. So to find the distance here between these, the distance squared, remember the law of cosines said you take one side, square it, and I'm going to call it R1. And then over here in my kind of red color, I'm going to take the other side distance and square it. Then you subtract 2, multiply the two sides, and then you take the cosine of the angle, and I ran out of room. It would be our theta 2 minus theta 1, because we could subtract them to come up with it. So I'll obviously show you an example that has numbers, but it all comes from the law of cosines because I have the two side lengths and I have the angles in between them. So let's draw these on here. So -3 comma 120 would be, 120 is 90 plus 30, 120 is this one. Okay, so here's 120, and then it's -3, so I have to go 3 backwards on this. And this is my point, -3 comma 120. Okay. And then let's do my other one in a different color. I have 4 comma 225. So 225 is a 45 degree angle. I remember that's my solid dark line. So here's 4 comma 225. And then I could draw this in. So like this distance here is 4. And this distance here is 3. And the difference in my angles is how much? We would do, if I think this is 360 minus 120, 240 is this angle. So in between would be 240 minus 225, which gives me an angle of 15 degrees, I believe. So that'll be my angle that I'm going to use and my two side lengths. Okay. So R1 in this case is -3, and then it's R2 would be 4. And then what do I have? I have theta equals 120 and theta 2 equals, and that should be 225. Okay. So using my formula, I have distance squared equals the first one squared plus the second one squared minus -3 times -4. Oops, I forgot my 2 times the cosine. I ran out of room again of, and I'm going to say 240 minus, I did something wrong here. Should stop and think about what I'm doing. This wouldn't subtract 120, so it shouldn't be 240. This is the worst part about doing them online, is you guys get to watch my mistakes. Oh, I erased a lot there. Okay. So it is 15, 30, 45. It is -60. It should be 300. I knew that looked like it should be 300 minus 225 would give me an angle of 75 degrees, and that would be much better because 225 minus 120 is probably also 75, and then, well, you guys know me. So I've got 9 plus 16 minus, and then 2 times should be 4, 12. So plus 24 cosine 75. And when you work that out, and of course I don't have a calculator in front of me, so I'd have 9 plus 16 plus 24 cosine 75. I got 31.2, and then I need to square root that. So I got 5.59-ish as my answer. So that would be the distance here between these two is 5.59. That is the end of day 1 for notes. Okay, so you found all this. Then when you're flipping through your packet, like you'll find all the notes here. And then if you go to the end, I don't have it, but you'll go to the end and it says day 1 homework, and that's where you want to start the day 1 homework.